Hi, I'm Dimitri.
Hi, I'm Georgina.
We're at Global Day of Code Retreat, and we're going to do the classic game of life problem. So we're going to do it with TCR constraint, which works as follows: is you cannot commit code without running tests. So if you run tests and they fail, like in this case, your changes are reverted. But if they pass, it will do like 42, then they're automatically committed their code. And we're going to do something like ping pong.
Yeah.
So for the game of life, do you think it's okay if I start like empty grid stays empty?
Yeah, sure.
That's a reasonable thing.
Yeah.
Empty grid stays empty. So let's say we have a grid, and then what should we call this?
Next generation.
Yeah. And then it should equal empty grid.
Okay.
Should I implement grid, or it's your responsibility?
As you wish.
Okay, I'll create.
Put the frame, the skeleton in. And then...
Yeah, so member function grid.
Okay.
And don't run it.
Okay. Yeah. Okay. After try not to run it. All right. So I think here we can just say return grids.
Yes, I think there is a small problem is that equality on objects.
Okay. Will it check the address, the address rather than? Okay.
It's going to be pretty much like Java equals. Right?
Okay,
so we need something.
Do we need to use like a data class?
Yeah, you know.
Yay! I did another session earlier, so.
Okay.
And we don't need brackets. Do we need brackets there? It's got no parameters.
The problem is that for data class we need at least something, or you can use track.
Oh yeah, I forgot.
Yeah, so
we could have dimensions or
whatever we want, or just anything will do. I think if you say val foo of type.
Because we don't know what it's going to be yet, and then we've got to give a type, haven't we? So we just I don't know, number, int.
Yeah.
I don't know. We don't know what it is yet.
It needs to be val though before foo.
Okay.
Because it's a property and so on. So and then
we would need to put in a 1 or something.
Yeah, but then they will have all to be 1. Maybe we can have default value. Maybe that's the need.
Do we put the default in here?
Just after int.
Is it colon?
Oh, just equals.
Oh, equals.
Whatever you want.
Okay, then it's
this
backward.
will work, I think.
Okay, so is it same? Can I run it? Should I run it?
Yeah, I have different shortcuts.
Okay, what's your shortcut?
Shift F10, a bit old school.
Shift
F10.
F10. Cool.
Yay.
Nice. Okay, shall I write the next test and then you can do... Shall I write the test? Or?
Yeah, that will do this thing. This will be...
Cool. All right, so we want another test. Oops. Function. So shall we do a grid with one cell becomes empty? Because that cell would dive into it.
Sounds reasonable.
So we have a grid. Next generation. Oops. So we need to pass in maybe like an initial state or...
Yeah, sounds good to me.
So how should we represent this grid? Like an array or...
Whatever we want.
An object?
Yeah. The easiest for me to also have a cell which represents a living cell.
Yeah.
With coordinates.
Sure.
To me it seems like one of the simplest ways to do it.
So like an array of cells?
Yeah. Or set.
Set of cells?
Probably a set, right? It doesn't matter the order.
Okay.
It's irrelevant, I guess.
Is that just... Oh no, we don't have to give a type here. So if we say cell... But we want... How in Kotlin do you say...
New object.
No, like if you want a set of cells.
You say set of.
Oh right, like that.
That's a lowercase.
Okay.
Sorry, it's a function name. Set of uppercase of. Like,
I see. Right.
It's a function name, and then you parent and you do whatever.
Like that.
Yeah, that's
And that will have some XY coordinate.
Yeah.
So let's just say 0, 0.
Yeah.
But would that be an object as well?
Yeah, we can also make a data class cell.
Yeah. Put that here, yeah?
Yeah. Yeah, we can have multiple classes per file. No.
Excellent. Which will be int, I guess.
Yeah.
And then y position int.
Yeah. Also, no new keyword, but I bet you noticed that you knew that.
Yeah, I kept tripping up on that in one of the earlier sessions. So we have a set of cells, which is our starting state. I guess that will be a val as well. We can pass that in here. So we need to update this.
I think you can just Altimeter.
Yeah, probably.
Just,
yeah, that's right. Okay, and then
might change one. Yes.
Oh yeah, of course. Oh, so our default should just an empty grid, an empty
set.
Empty
That's
set.
a function name as well.
All right, excellent, like that.
Yes.
And then that allows for the first one to be backward compatible.
Yeah, but I think it's just gonna work. I think we can already run that. Right?
You want me to run it?
I can run it. It's a ping pong, but if you give it back to me,
you run it. Yeah, you ping pong.
Yeah, I'm supposed to implement that, right?
Yeah.
So, and I say it's already implemented. I'm gambling on it being correct.
Well, we're only returning empty grid every time, so I think you're right. Phew.
Yeah, well, we changed a few things. I'll do some formatting and run it again.
Sure.
It's like a save button, except that I wish compilation was a bit faster. So so it counts as ping pong, right? I implemented it, but I'm not doing anything.
That was lucky for you.
Yeah. So then also grid with two neighbor cells also becomes empty. Two. It's pretty much the same, right? And it will be easy for you. So I think that
should also be fine.
Well,
what's the rule? Sorry, it dies, doesn't it?
Yeah, I think it's the first case we have because they don't have enough neighbors.
So it dies.
So you need to implement that now.
Let me implement that hard case.
Okay.
Probably fail now. Typo or something. No, okay, we're good. So, how do I get rid of that? Did that now?
Yeah.
All right, so another test. I guess should we just go down this list maybe?
Yeah, sure. That looks convenient visualization.
Yeah. So this one has two neighbor cells. Oh no, we've done that one. Sorry. We've done that one. So this one's got three neighbor cells.
The grid with two neighbor cells, and this one is with three.
Oh, I see what you mean now. I was thinking an individual cell had two neighbors there.
Right.
Yeah.
Okay.
But I understand.
It says grid with two.
Yeah.
That's why I was thinking.
So this is, so now we're doing, so we've done this one, we want to do this one with three neighbor cells, yeah. Becomes empty, so we want...
Oh, it doesn't become empty though.
Oh, sorry, no, you're right.
So the case
becomes one cell?
Yeah. Maybe we should go for actual rules and say cell with two neighbors survives or something like that.
Yeah, I think that would be more descriptive. I'll get rid of this. Survives. So we've got 0, 1, 1, 1. And then 2, 2, yeah.
And what we're saying is that 1, 1 will survive?
Yeah, so we would want, maybe we want to get a list of live cell coordinates or something?
That's what I was like, dot whatever cells.
Live cells?
Oh,
live cell positions?
Oh yeah, it's called foo right now, that's not...
yeah, we should change that.
Yes.
Live cell?
Yeah, sounds good to me. Live cells.
And that returns what, the positions, or I guess?
It will just return a set of cells. It's just,
Okay.
I think we could rename foo to that.
Do you want me to do that now, or do you want to do it as part of? We should probably do that as a separate thing.
Okay.
Yeah, so we don't. So that should equal a set of cells with 1, 1.
Maybe. Yeah. Yeah. Sure. Sounds good to me. So, yeah.
Okay. Should I make this compile and then pass it over?
I would not even create a function.
Okay.
Can I
Yeah.
take
Yeah.
over?
Yeah. Go for it.
What I meant is that you could do just that.
Okay.
Just do live cells like that. Then we don't need the function.
And is that because Kotlin generates you? Is that really calling like a getter underneath,
Yes,
opposed to accessing a private property kind of thing that you have in Java?
Yeah, it will generate getter and setter.
Yeah, cool.
So.
All right. So if you run that, I'm pretty sure that would fail.
Yeah,
so
I don't want to run.
I think we should. I think you might want to implement.
Well, do you have a good idea how to?
I mean, we could hard code it if you wanted for now. So we need a live. So do we need to define the getter essentially because we want to? You know how Kotlin will generate you a getter from the data class.
Yeah. But sorry.
Oh yeah, sorry.
But you mean? My understanding was this.
So we need to. Yeah, go on.
Live cells are all of these cells. Right?
Yeah. So we're returning the wrong type here.
No, we return in a grid. But it has cells. My idea was that we maybe eventually have survived cells, and that could be a variable, but that's then we can filter live cells to only include survived again one more time.
So we need to. I suppose my question is: this live cells function is being called on the grid that's being returned here. And so the grid is just maintaining a list of surviving cells.
Yes.
Yeah. Okay.
Yeah. So it's just a state of the grid essentially.
Yeah. Sure. Okay.
Well, that's one way. If you have another idea.
No. Just wanted. Yeah. Just keeping in track.
But then this is going to be implementing everything.
Okay.
Or should we take smaller steps somehow? Or you think that's okay?
I guess. If you're doing something like baby steps, you would just probably do the obvious stuff first. But if you want to filter, just go for it.
I'm just kind of think of something simpler, but that's not very simple what we're going to do. That's why I'm like, oh no.
So you're going to. So what are you going to do in here?
I was thinking. So what we want, we get a cell, and then count neighbors, right?
Okay.
And that should be leaving cell is equals to pass the test.
Sure.
So then we do that, and I guess we need to set as well. That's okay. So now we need to implement this.
Okay.
And so yeah, that was my plan. Which is
so it's just like one cell, correct or not?
Yes. Yes, it is. I can do this maybe slightly different formatting, and we can do this like a cell explicit name, or go to its neighbors, and then count neighbors. That's like the next thing.
Okay.
So how would you?
You could just hard code that to 2 for now.
Will it work though? Because there are other cases.
Good question. Well, you'd have to hard code all the cases if you're doing that.
So maybe you could do something simple. Or should I go for everything?
Or just go for it.
Okay, fine. It's gonna be very long. Okay. Yeah, let's do it.
Okay.
Neighbors. How do we get all neighbors?
So in the set, obviously when you visualize this 3x3, that's more like an array sort of in my mind.
Yeah.
How would you visualize this set? I mean, the same? These are indexed, so you can find out what's above it, below it, etc.
Yeah.
But in a set, how do you know what's next to it?
Oh, but they all have coordinates.
Yeah, of course. Yeah, they have coordinates. Okay, fine.
I'll just type something I have in mind. So for neighbors,
we just need to increment sort of each direct. We have to do math to the coordinate.
Yeah, maybe I'll try to more Kotlin things. So we could do sequence, which will generate things from say -1 to 1.
Okay.
And we do for each. That's going to be X shift. Then you could do Y shift. And then we're going to do yield, maybe cell. So there is current cell, which is x position plus x shift, if it makes sense.
So where's our current? So what does sequence do again?
It generates a lazy collection.
Okay. And how? Oh, this is what we're iterating over. This.
So that's a cell, right? So
yeah. Okay. I was thinking, like, where's the cell?
yeah. Oh well, the current cell is this extension function. Have you seen this?
Right. No, I haven't seen that.
So we can do this.
So why would you not just put that in cell?
We could.
Okay. So this is just an alternative.
Yeah, but then so that's all the neighbors with the absolute, like there's just neighbor cells.
Yeah, all around.
Yeah, so Y shift. So that's a thing, but then we need to access live cells to see live neighbors, basically.
Okay.
So my plan was to do we return neighbors, but we filter them, so cells contains live cells. Sorry. Live cells contains it. Oh, we don't need this, we didn't count. So it's like filter and count, so that's...
And where's live cells come from again?
Well, it comes from the grid. So that's why
okay.
It cannot really be defined on cell.
Okay, so this way you can access everything from cell and everything from...
So maybe that's less confusing, I'll call it off. That's a giant step, though.
It is, yeah.
I think there is also one missing thing, because it will count itself here with this loop. Right, so we also need to do something like if x shift not equals 0 or y shift is not equal to 0, then we yield. Right, something like that. It's a bit complicated.
It is a bit, yeah.
We could have hard-coded all that.
Yeah, I mean, it's all this...
typed
anyway,
for so long now.
What if you're what if, you know, like again in an array, you might go outside the boundary of the grids. I guess this doesn't matter here, like because we're only.
Yeah, then because we're then filtering through this, we're counting only live cells.
Okay.
So we're only keeping neighbors which are in the set of live cells.
Okay.
So, do you have any objections?
No, go for it.
Yeah, if it fails, I think it will be your turn anyway.
Oh no. Good, well done.
Wow. Okay, I'll write something simple.
Okay.
Cell with 2 neighbors with 3 neighbors survives? Yeah, that's the thing, right?
So 3, I don't know, yeah. It's with 3 neighbors survives, whether it's alive or dead.
Rules are dead,
yeah.
So let's maybe add 1 neighbor to the right of the cell. Maybe 1, 2. And live cell. Maybe it also should be like contains. Cell 1 should equal true, something like that. Maybe I'll do this.
Okay. So we've got 3 neighbors. Oops, scrolling the wrong way. So we've got set of 0, 0, 1, 1. So we've got this line and 2, 2. Okay, so we're like this. So this has 2 neighbors. We're actually going to have a grid with one of them's got 2 neighbors, one of them's got 3, aren't we? Because if you draw,
yes, true.
So it's 1, 2, 3, 4, isn't it? That's the 4 cells.
Yeah.
So this one will die.
No, it will have 2 neighbors. So
2
it
neighbors.
should survive.
We've got 2 neighbor cells become empty. It dies on that one. Oh no, hang on, have I done... I think, hang on, like 0, 0, 1, 1. Oh, it's this one. 1, 2 is here, isn't it? Okay, I finished reading. Okay, so I think we're all right.
Yeah, I wasn't really visualizing this. Like this plus 1 in any direction is a neighbor of 1, 1 anyway, so that's why I was like, should be safe.
So it should work, shouldn't it?
I don't know. I think this is 2 on line 41. It says equals 2
right, so we need
exactly.
to put in the different rules here.
It's 2 or 3 maybe. That's
Yeah,
what
so
I was thinking.
we'll filter if the neighbours of the cell is 2
Or 3 then.
or 3, it should live. Yeah, okay. Is it just the same like this?
Probably, yeah. Well, let's hope it is.
It could be 1 or 3.
Equals 3. Yeah.
Okay, should I run it?
Yeah.
Except when
Good.
Excellent. Okay. So if we have another test. So if we have 4 neighbours, it dies.
Yeah.
yeah, there's
Dies. Does not survive. So we've got 0, 0. So we need to have like 4 like this, don't we?
The way I think, maybe it's like worth mentioned in test. I was always thinking like cell 1, 1 is the cell we're actually thinking about. So if I had 1 more neighbor, like in whatever direction.
Oh, as long as it's 1 something.
Yeah, that's the way I was thinking about all our tests. It's just based on this visualization. When we cover it.
So if I say 1, 0.
Yeah, should work. I cannot like easily visualize that, but it should be correct.
This should be false, yeah. Okay. It's hard not to run the test. Not to run the test after you've written the test.
Wow. How did I do that then?
So it's not going to be.
I think it will just work, right?
So if it's 2 or 3, oh yeah, because we've got 4.
Ooh, easy job for me.
Maybe.
Can I run?
Yeah, go for it.
absolute symbol meant to say that absolute symbol.
Whoa.
Brilliant.
Okay. Well, I could go down this path, I guess, and say 5, but it's still gonna work.
Yeah, it's just going to work for anything
I'll
more.
do the
isn't
hard
it?
thing for like creating a new cell. Right? So what's like empty space with 3 neighbors.
Becomes alive.
Yeah, becomes alive. So what did we have there? 0, 0, 0, 2. I'm copying what we have as an example. 0, 2, and then there is 1, 2. I think that's the thing. And then we expect this to be true.
So that's like 0, 0, 0, 2, 1, 2.
Yeah,
no,
that's
it's not.
wrong. 1, 2.
1, 2,
It would work anyway, but I
and
was
then
0.
2, 1, that should be.
Okay.
Yeah.
Yeah, thank you.
No worries.
Well,
And is this, 1, 1.
is in the center.
1, 1, yeah, okay. All right, so, God. Oh, I keep scrolling the wrong way. So it's not going to be in this. So it's like we want to take the non-survived cells and check their number of neighbors.
Non-survived. We want even empty cells.
The dead cells.
But they're not necessarily dead. They could be not even in this list at all.
Okay, because there's just nothing next to them.
Yeah,
right.
We don't even have those objects.
Yeah. And it could be a massive grid that you can't...
Yeah.
You don't know how many there'll even be. Okay, so... So we've got these cells, our starting states. If any of them have 3 neighbors, it becomes alive.
Yeah, one way I was thinking about this, we could go around all the neighbors of living cells and look at those, because if cell is not even close to any living cell, then it cannot come to life at all. Right, so that's one way to...
So if a cell is not, say that again?
If we have a set of living cells.
Yeah.
So if we just go around them and find empty cells
Right.
around them, then the set of those cells,
right.
of all possible neighbors, this is the only set that can come to life. Because
right.
if you're like further away,
there's nothing joining them up.
Yeah,
no
so
neighbors joining them up. Okay. So if we So we go through the live cells, we find the neighbors, which we've got here.
Yeah. This makes me think maybe, yeah.
And then we want to see if any of them have
yes.
3
yes.
neighbors.
Yes. That's like one way to do it. Yeah.
Which sounds kind of recursive.
A little bit, yeah. Not the most efficient way.
So it's almost like you'd want to count the number of neighbors for each cell, for each live cell.
Which is a neighbor. No, we want to count number of neighbors for each neighbor of a living cell.
Yeah, okay, so these are the neighbors of the living cells.
Yes.
Can I just rename that?
I would suggest, the trick I used before
Yeah.
with TCI, because we cannot run, but we kind of want to run, we could comment out the latest test and just to use it as a save button, like this test is not ready. I would just comment it out, do refactoring to whatever we want. So if we just comment out the last test, then we can...
Can we just ignore it, like in...
Let's try.
Or you think it's safer?
Well, let's run, let's see.
Oh no, well it hasn't compiled.
Oh, it's they're on ignore annotation.
Oh, right, okay.
Some JDK thing. Maybe it was the wrong import.
Maybe. Does it offer another one?
Oh, didn't see.
Or...
No.
No, okay, so let's just do what you suggested.
I think also
I think we've got
one
that.
more line.
Oh, yeah?
And it,
Oh, yeah, of course. Thanks. So if we run this now, the test will pass, we think, and...
yeah, in a way I was thinking about CI.
It's a bit naughty, isn't it?
It depends on what is the purpose. I've been thinking about maybe it's a metaphor for deploying live. So it's okay to deploy live some commented out code.
True, yeah. Yeah, but this is commenting the test, which is like not even going to have any effect in production, whereas it might...
Well, at least we're not making it worse.
So what I was thinking was just to neighbors of live cells, just so we can just be more explicit there. And then we want to get the neighbors of this set. Don't we?
Sorry, these are not neighbors of live cells, it's like neighbors of current cell. So we have a cell which comes in as a parameter like
we didn't.
60. Yeah.
But that is the live cells, isn't it, from here?
Yes, yeah.
So I think that's correct, no?
I mean, the name is a bit misleading because it's neighbors of one live cell.
Oh, okay. Yeah, okay. Of single live cell?
Yeah.
Okay, so that's neighbors of one live cell. And then we are saying, is it 2 or 3, then add that to the set, right? Of survived cells, okay.
Yeah, maybe it feels like maybe we should have a function which just gives us all neighbors of a cell.
Yeah,
like,
which is
this, pretty much. Yeah.
So if we move this out to a function, get neighbors of cells.
Yeah, sounds good. Yeah.
And then that happens to be a single live cell, which is fine. But let's just call this...
In line, I think if you Altimeter, it just tells that
perfect.
used once.
So now we want to go through the survived cells and count the neighbors of them. Is that right?
Or live cells.
So we have our starting state. We've gone and we've got the neighbors of each one.
Yes.
And we want to then see if that neighbor has how many neighbors it has.
Yeah, yeah. I think survive cells like the next generation of live cells, so we want to go through live cells, I would think. We can try what, you can type something. As long as it has no side effects, we can still run tests and they will commit. So even now we can run tests, it will say.
But the thing is, if I go through live cells, it's going to get the neighbor of the same. It's going to be the same as what we just did, isn't it?
Yes, but then we need to filter them. So here on Line x64, we're filtering by a live cell contains it. And then we should probably do it the opposite, like filter them so live cells don't contain. So these are the neighbors of live cells which are empty.
Okay, so let's do... So what should we call this? Neighbors of
live cells? What you called it before?
Okay, neighbors of live cells. So we've got our live cells. We want to do the same as this, right?
Yeah, almost. Yeah.
Filter. We can remove duplication stuff later. So we want to count the neighbors.
Yeah, so we want to get neighbors first, right?
Oh yeah, get neighbors. Sorry, yeah, get neighbors of it. Then we want to. Then we want to see
of those neighbors. We want to find
their neighbors.
Yes.
So we want to get neighbors of that. I don't know how to write this.
I think.
And I don't know why this is not happy either.
Because it wants a boolean and we return in not boolean.
Oh, I see. We just say map or something.
Yeah, let's do map. That's gonna work. And then we can run. Let's just run that.
Okay.
Like to experience whatever save button. Postmodern.
Oh, phew, it's still green.
Yeah, so at least we saved this.
Okay, so we have a neighbor of our live cell. We want to then call get neighbors of this, whatever this returns. We want to call get neighbors of that.
Yeah, I think also like map is good, but maybe it should be flat map. Because you can also go to like one line above and say, to the definition of the variable and say Altimeter, like do specify show type explicitly.
Here or? Yeah, show me.
So you can do this. And that's a list of sequence.
Okay.
But we want probably just normal list or something.
Right.
And so maybe if we try, doing it now, so like flat mapping is, then, that needs to be a list because it was a sequence. But so now if I do this,
simplifies it a bit, yeah.
Yeah,
okay.
So it's just neighbors. But I think we also need to filter to make sure those are not living cells. So all right, to see if the neighbor's not a living cell. Yeah.
Yeah.
So
if we filter now and check that it is not in live cells.
Yeah. Then we get like the set of potentially cells.
So live cells.
It needs to be curly braces.
Okay. So like live, can we, like, doesn't contain?
There is no function doesn't contain. There is like.
Or like contain or.
There is thing you can say in and not in.
Okay.
Not in is exclamation mark.
So like
in.
it's.
Exclamation mark in. In.
Not in.
No, exclamation mark.
Oh,
means
is not. I got you.
Yeah,
not in live cells.
Yeah, that's one way to do it. Doesn't contain. You can run this again.
Yeah.
And the way I think about it, if you deployed it to live, that would be okay.
Okay, we're out of time, I think.
Yeah, cool.
Oh, it was good.
Yeah, cool.
Yeah, interesting. I think in a real system, commenting the test, obviously, you're saying, we're just commenting out the code that would be running. But because this is like potentially production code, this could affect, in theory, something that is running in production.
Yeah.
And therefore potentially has a risk. Not in this example, but in a real system.
Yeah.
I've never done that test commit thing before, so yeah, you have to be confident that you don't want to lose.
We were kind of lucky, not especially the first time I typed for 10 minutes or something.
Yeah, you did the complicated bit. Yeah. Oh, very good. Cool. Very interesting.
Yeah, cool. I guess they're stopping here.
Yeah, sadly. Just always as we get to the good bits.
Yeah, so thanks for watching. Bye.
Yeah, bye.